Welcome to Data Skeptic All About Surveys, our season about survey design, interpretation, and methodology. Let your voice be heard at survey.dataskeptic.com. Today on the show, I have two researchers from the CORE Robotics Laboratory. Although we're going to discuss Likert scales and their deep connection to our All About Surveys season, let's do a quick tangent and get back to that. At some point, there might be a whole season on robotics on Data Skeptic, and we'll probably have to have Mariah and Matthew back. My personal academic journey, professional work, and interest really has always kind of focused more on the AI than the robotics. I want to build the software part, not the hardware part, myself. In part, that's because when I was younger, I thought robotics were a lot further off. And maybe that's right, we're getting close with some recent advancements in AI. But I'm actually 50-50 on if we have a lot of AI software or a lot of robots in our life first. From automated vehicles to retail applications or home bots, these devices are becoming technologically feasible very quickly, even if they're not artificially intelligent. Yet we know a certain degree of intelligence is going to be inside all of our devices. Well, maybe not our toaster unless you want it. So if you, like me, take it as a foregone conclusion that there's going to be an increase in robotics in society, it is very important for people to study and understand human perceptions of robots. Are we afraid of them? Obviously, safety is our top concern, but after safety, there's usability. And to wrap up our tangent along similar lines, I just heard about, I haven't read it yet, but I just bought The Age of AI and Our Human Future by three unlikely authors together, Henry Kissinger, Eric Schmidt, and Daniel Huttenlocher, who I have to confess I don't know. This and a couple of other recent publications, Stuart Russell's comes to mind in particular, are amongst the canon of good, let's call them armchair science books that are targeted at a pretty broad audience to explain AI. I want to develop a survey to see which of these books the audience thinks are important, or even which books you've heard of, that kind of thing. But before I launch that survey, do me a favor. Today is April 3rd, 2023. I'm going to give you 10 days, so if you hear this before April 13th, if you've got a good recommendation about a non-fiction book related to AI, job loss, robotics, all these kinds of topics that are prognosticating a bit about what's in our future, please send me an email. It's kyle@dataskeptic.com, and I get a lot of emails, so please do this next part very specifically. In the subject line, put book recommendation first. Book recommendation : the title, but start it with book recommendation so I can do a search later. I'm going to do that search, as I said, on April 10th, 2023. I'm going to gather all your recommendations, put them into a survey, and then I'll announce that probably in 2 weeks on the show. I haven't formalized the exact question I'm going to ask in that survey yet, but the point is I want to gauge the audience's perception of what are the most important works on this topic. We'll put a reading list together. Hey, maybe we'll even have a summer book club thing. So if you suggest a book, let me know if you'd be interested in participating in something like that. The dust jacket of this book and thinking about what goes on at the CORE Robotics Lab has got me more interested in understanding the way this topic is being communicated to the public. But back to the content for today's interview. Both the topic of the survey we'll discuss and the mechanism are interesting. We discuss details about human robotic perceptions, and we do a nice zoom in on the Likert scale in particular. What it is, how it works, how you can use it correctly and avoid using it incorrectly, and a few other pro tips along the way.
My name is Mariah Schramm, and I'm a fifth-year robotics Ph.D. student in the CORE Robotics Lab at Georgia Tech.
And I'm Matthew Gombolay, an assistant professor in the School of Interactive Computing at Georgia Tech and the director of the CORE Robotics Lab.
Well, let's talk a little bit about the lab to kick things off. What kind of activities go on there?
It's an exciting group of young, bright individuals that I get to work with in my laboratory. And our goal is to enable robots to come out of the laboratory, out of the cages, and into your everyday life. Our view on this is that we need to put the human first in human-robot interaction. And we want to enable robots to first learn models of how you think, how you act, how you behave, so that robots can have the same skill sets you can. If you can fry an omelet, maybe you could teach a robot by demonstrating the task for the robot. The robot can use sophisticated machine learning techniques to kind of reverse engineer that behavior by watching and interacting with you. And then we want robots to be able to explain what they learn to people so that people can understand what the robot learned and maybe correct it if the robot learns something incorrectly. And then finally, we want not just to stick with the human robot team, the one-to-one interaction. We want to scale this up to large scale teamings for manufacturing, for search and rescue, by understanding the strengths and weaknesses of each member of the team and figuring out the right roles for that interaction, understanding the effects of trust, trustworthiness, whether you're going to actually rely on the robot or adopt it. So we can design the interaction so that you're not just led to believe the robot's amazing when it's actually not. And also so that you don't just reject the robot when it does have something of value to offer you, when you may just be skeptical from the beginning.
And Mariah, can you tell me a little bit about some of the things you've gotten up to in the lab?
Yeah, so my research is primarily in algorithmic human-robot interaction. So algorithmic human-robot interaction focuses on how we can develop these novel frameworks to enable robots to be aware of their human end users and then improve upon the ability of these robots to interact with human end users. And so my thesis work has primarily focused on developing novel data-driven frameworks to personalize a robot's actions and behaviors to account for heterogeneity amongst end users. And so in my work, I want to also make sure that we validate these novel frameworks that we've developed in large human subject studies with real human subjects. And so in these human subject studies, we need to be able to evaluate an end user's perception of the robot. So that's why I'm also interested in the psychometric side of human-robot interaction.
Well, I've spoken to chatbots. I don't think that's considered a human-robotic interaction because it's purely software. Where does the line get crossed? At what point am I interacting with robotics?
Many of your listeners may have heard of ChatGPT at some point in some conversation. When I play tennis leagues for fun outside of work, and my opponents, then I find out I'm a professor in robotics. They're like, "So what's ChatGPT? How does this thing work? And is it like going to be something I'm going to use in my job every day?" It's a very impressive machine learning model, of course, but it's not a robot. Robotics requires, yes, intelligence, artificial intelligence, the kind of computational representations or mimicry, trying to emulate how humans think and put that in a computer's form with lines of code and with central processing units, yes, and memory. But you have to put that system on something physical that can act within the world. There's a significant difference between a system that has to learn how to interact with the world, where your actions as a robot have physical consequences. As soon as I go try to make an omelet in the real world, if I knock the egg over, somebody's got to clean that up. I've changed the environment by knocking the egg over. But if you're ChatGPT and you say, I'm going to crack an egg, there's no egg. It has no idea what an egg is or what crack is in the process of opening the egg. It just knows that these words go together. And so this idea that we have to ground our language, what we think through, in physical objects and how they interact with each other is a really fundamental difference. And in particular, when it comes to humans, as soon as the robot starts having certain characteristics and interacting with a person, the human's going to change what they think of the robot. The human's going to adapt, change its characteristics. And now whatever model the robot had of the human now has to be updated because the human has now changed how they behave around the robot. And so it's this feedback loop that's very complicated that you don't really have to deal with in a lot of what you say, more computational challenges that more traditional, like supervised learning, computer vision, kind of this like virtual intelligence that you see with ChatGPT.
Well, a lot of the machine learning I'm familiar with has a well-defined like objective function or loss function, something mathematically you're trying to go for. When it comes to the output being an omelet, I think there's a variety of opinions. I don't know if there's one perfect omelet that's going to win the gold award. How do you go into it and take more soft science approaches to measuring something from your domain?
Very interesting question. Yes, so there's a spectrum of how we actually measure a level of goodness. There's going to be person-specific preferences. I may like my egg a little more runny than somebody else. And that can mean the difference between somebody saying, I'm going to send this omelet back to the kitchen to get remade, or they're going to take it and they're going to eat it and they're going to love it. people will reject things that when their preferences aren't satisfied. So a lot of the work that we do in our lab, as Mariah was alluding to in her thesis of heterogeneity, humans have unique preferences and their own views of what optimal is or what's best for them. And we try to not just learn a person-specific model, because now you're going to have to work for hours and hours and hours to train the robot all by yourself. Giving it all of that experience to learn from is going to be too much. So we try to say, let's learn from everyone what's common about a generic omelet. Like, it should somehow be cooked, generally folded over and fried in a pan with some oil in it. That there's all these things that are common. And we can learn a little bit from everyone about what that commonality underlying task reward is. And then maybe we can leverage that to then personalize to you how you like it. Oh, you like it with some ham and some cheese and a little runny, or not. This really ends up becoming a big challenge when we deploy these systems in healthcare environments, manufacturing environments, where there's objective standards for like life and death, but it's not easy to know today how a patient is going to turn out 30 or 40 years from now. And that's where like this really uncertainty in metrics and defining it is a key focus of people across scientific disciplines.
Well, could we talk about the data collection process when you want to learn from the human side of the human-robotic interaction? How do you go about getting some data?
There's, let's say, two basic types of approaches. There's qualitative research and there's quantitative research and methods that you could go about it. I'm going to focus right now on what we call quantitative. It's basically methods like you have a clicker and you give a robot a good or a bad signal. Peter Stone, Brad Knox, and many other researchers have tried to develop that. Now ChatGPT is kind of using those ideas. It's called reinforcement learning from human feedback. But the idea has been around for a while. So there's this binary yes or no, or maybe you can grade it on a scale of 1 to 10 of how well it's doing. And then there's ultimately, did you just adopt it or did you walk away? Because a lot of people just walk away from the system. And that's objective data that you have of if you walk away or not. Did you accept the robot's recommendation? Did you tell it, no, I'm going to do the thing instead of you? Those kind of behavioral things that you can code as a yes or no, successful, unsuccessful, are helpful. You can do a lot of statistics with that. But ultimately, we also want subjective data. We want to know what you thought. Did you trust the system? Are you willing to trust it to do surgery on you? Are you willing to trust it to give you the right medicine? And that's where these subjective data come in play. And Likert scales are a key way of doing that. And so I would love to turn over to Mariah to talk a little bit more about what a Likert scale is.
Yeah. So as Matthew was saying, there's many different ways to measure a participant's subjective attitude towards a robot. And Likert scales are one method that have commonly been used in the field of human-robot interaction. And so these Likert scales were created in 1932 by Rensis Likert. And so they have a very long history in psychometrics. They were originally designed to scientifically measure a respondent's attitude. And attitude is basically a respondent's preferential ways of behaving or reacting based upon their beliefs and ideas. And so a common example of an attitude that we measure often in HRI is trust. So how much does someone trust this robot that they're working with? And so a Likert scale is composed of a set of Likert items in which the respondent must rate their level of agreement for each of these items. And then their responses across all of these items are summed to form a composite score representing their attitude about a specific topic.
Right off the bat, I think most listeners will be familiar with the Likert scale itself, but maybe also have some questions about it methodologically. Sometimes it's a wide number of options. I've seen it go as high as 10 or more. Sometimes it's very few. Sometimes it includes the middle point, like a point of neutrality or not. Are there robust ways of thinking about the proper way to use it as a measuring tool?
Yes. So that's why we conducted this review of the psychometric literature so that we could determine what are the best ways to actually design Likert scales, employ them when measuring attitudes in HRI, and then actually analyze the data. And so there's been a lot of work in psychometrics that has investigated all of these questions that you brought up. How many items should we have in the scale? how many points on the response format? Do we have a neutral midpoint? Some of these questions there's actually controversy around, and it's not actually been decided what the best way is, or some of the answers may depend on the specific circumstance that you're using the scale in. But one thing that is pretty common held belief in psychometrics is that if you are attempting to measure a complex and multifaceted attitude, for example, like I said before, trust, you should utilize at least 4 items in your Likert scale, because less than 4 items, you're just really not going to be able to capture the complexity of this construct. However, you could have as many as up to 40 plus items in your scale, and the maximum number is really just dependent on how long you want your survey to be and potential survey fatigue of participants. With regards to the neutral midpoint, this is a little bit more controversial. So some suggest that you should include a neutral midpoint because in some circumstances, it's actually accurate for someone to not have a strong opinion about whether or not they trust a robot, and they would accurately answer neither agree or disagree in that circumstance. But having a neutral midpoint can also cause respondents to pick this answer as kind of an easy out because they don't have to choose one side or the other. And so in our work, we suggest that if an HRI researcher is investigating a question about attitude in which the end user has actually worked with the robot and has experienced the robot. So for example, if we're asking about how much a respondent trusts a robot and they've actually worked with this robot, then we suggest that they do not include a neutral midpoint, because the respondent should have some idea about their feelings regarding trust of this robot. However, if you're just trying to get a participant's preconceived notion about a robot before you start conducting a study, then it can be beneficial to include a neutral midpoint, because someone who's never worked with this robot before may not have a good understanding of their trust of the robot. So it makes sense to include a neutral midpoint. So I think a lot of these questions are pretty nuanced, and it depends on the circumstance in which these questions are being researched.
Are you a software engineer looking to make an impact with one of the world's premier data and technology companies? Well, you should look into Bloomberg. Bloomberg is building the world's most trusted information network for financial professionals. And right now, they're looking for engineers to join them. For me, there's 2 critical features when I would consider a new role. Impact first, job security second. Well, in terms of job security, you can look up Bloomberg and see how long they've been around. But more importantly, in terms of impact, you'll be part of a team that builds and delivers tools to help the world's leading business and financial decision makers surface relevant information in an ever-changing ocean of data so that they can act quickly on it. I once had a job where after completing a really big project that would do fraud detection and elimination in our system, the CFO blocked the project because he was worried it was going to hurt our cost of goods sold. So my solution went on the shelf, and the company I worked at continued to defraud its customers. I didn't stay much longer, and the company isn't around today. It was a sad outcome when a really cool solution went on the shelf. But if I had worked at Bloomberg, that wouldn't have been a problem. Their software engineers build solutions that are relied on by more than 350,000 financial professionals all around the world, using them to make critical business decisions. Bloomberg believes in using the right tool for the job. Their stack includes C++, JavaScript, TypeScript, and Python, all languages I love. The company is committed to building a diverse workforce full of fresh perspectives. Finding your new career can be hard, but if you find the right company, it can be rewarding and fun. So if you're in the market or just thinking about what your next move might be, learn more about this opportunity by visiting bloomberg.com/careers. That's bloomberg.com/careers. This episode of Data Skeptic is made possible in part by Mimecast. You're wondering if you need more email and collaboration security. After all, you've already got M365 protecting your workplace. That's good enough. What more could you need? Well, a lot really. What if one of your employees just opened a phishing email and M365 couldn't handle it alone? Now your company has to ground to a screeching halt. Transformers stop transforming. Circuit short circuit, all because of a single email. Like they say, just one match can burn this town. Next time, take 5 minutes to set up Mimecast, a security solution specifically designed for email and workplace collaboration. It detects suspicious emails and diversifies your security stack so you're not just relying on one generic solution. Your inbox is important, so get another layer of protection for it and keep your business from, falling apart. For a free trial, go to mimecast.com. That's Mimecast, Mimecast.com. Well, my somewhat uninformed guess would be that most people use a Likert scale with not a lot of thought about these sorts of questions behind it. You just have a job to get done. You're trying to measure something. You throw up this question. You have the benefit or maybe the responsibility of having read lots of these papers over the course of multiple years. Do you have a sense of the degree to which most researchers had rigorous thought about this aspect of their work?
So we found that a lot of researchers, especially because HRI is a new field, they tend to create their own scales, which is completely understandable because there often aren't scales that already exist for HRI researchers to measure the constructs that we want to measure because it is such a new field. The problem with this is that when we're creating our new scales and deploying them to answer research questions, if these scales haven't been thoroughly validated using techniques in psychometric literature, such as factor analysis and measuring internal consistency and all these important components to the scale, if we don't put these scales through this rigorous analysis before using them to actually measure attitudes, then it can be difficult to ensure that we're actually measuring what we intend to measure. And so this was one problem that we found to be pretty common in human-robot interaction, basically employing scales that weren't thoroughly validated.
And I think that there's an unfortunate, perhaps, bias against research that actually goes into developing and validating scales to support the community because, first of all, it's maybe not as exciting as developing a cool robot to do something neat. You're like, I made a scale, and it's really important, but it's like a little tougher of a sell. And then maybe there's not as much funding for you to go and do that. It's harder to get your paper published because you're like, what's your contribution? But I am really encouraged by the human-robot interaction community that we're embracing the need for more of a holistic, systems-oriented and metrics-oriented approach for how we design and evaluate these studies. As Mariah said, it's a baby field relative to the field of psychology or sociology, but we're really at the cutting edge of developing and employ these systems in the world. And so that's going to need us to innovate to be able to measure these phenomena correctly and know if we're asking, are we measuring trust? Like, are we actually measuring trust?
And do you have any thoughts on best practices? Measuring trust is obviously a key component in human-robotic interaction. We want humans to trust the robots or they're not likely to interact with them. Can I just ask it at face value, or could you talk about the process for validating one of these questions?
Yeah, this is a very important topic. I come from a human factors background, so my graduate work was in aeronautics and astronautics at MIT, and we focused a lot on humans in aerospace and making sure that when humans are in a cockpit, they are appropriately relying or complying with cockpit automation. So moving from aerospace to autonomous driving, the National Highway Transportation Safety Administration is really faced with this dilemma of we have autonomous car makers or Tesla saying that we have autopilot, full self-driving. People have too much trust in the system, and then people are dying because they're not paying attention. But it's really important to note that trust isn't trust unless there's actually a risk. If I trust you to turn off or turn on your light in your room, that has no impact on my well-being. But if I hand you a knife and I say, I need you to take out a tumor, that's getting at trust. If we have a robot that's going to manipulate a welding torch around your face because you need to get in there and also do something in some kind of manufacturing activity, that's getting at trust because the robot making a mistake could mean your life or death. And so to measure trust, you really need to know you need to measure their attitude, their willingness to be vulnerable to some other agent and be willing to take a risk. And then trust kind of informs, is this variable that informs your ultimate behavior of what did you do. And what you actually do could change based upon your context. I could have all the time in the world and say, I'm going to drive my autonomous car, even though it's amazing and it's perfect, it's never going to make a mistake. You know what? This is just fun. So I'm just going to drive my own car because I like driving. But if I'm busy, I got the kids in the back seat that are like throwing food at each other. They're screaming, you're breathing on me. I might say, Tesla, autopilot, full self-driving, go. And its competence didn't get any better or worse. But my context significantly changed to situational trust. Now I might make a decision to rely upon the robot. That might have been a mistake, but it's contextual. To measure trust, we have to first understand that it's an attitude and then be able to go deeper with these Likert scales to get at what are the dispositional, contextual, situational factors that drive trust. And so most people don't get that trust is an attitude. They think it's just behaviors, and that they don't appreciate necessarily that risk is a significant component of trust. And then they're not actually measuring it. Or we develop Likert scales, and then you cherry pick where there's something interesting on your scale. You ask them 10 questions, then if there's one where people are responding very positively, then you say, oh, let's just call out that measure. When you need something that's much more complete, holistic, to get a sense of the overall picture.
And do you have any best practices or recommendations for how to develop good questions and good scales?
Yeah, so there's a whole process for developing Likert scales and ensuring that they actually measure the constructs that we're trying to measure. And so typically when beginning to develop a Likert scale, you want to come up with a large list of items, typically 2 to 3 times the number of items that you actually want to end up with. And often you want to make sure that you create these items based upon what the prior literature says about measuring these constructs, and then also using experts in the field to make sure that these items are likely to measure what you're intending to measure. And then there's this whole process to go through for item reduction. And so you can take all of these items that you've developed and have participants respond to these items, and then based upon the internal consistency and things like factor analysis, you can use these techniques to then eliminate certain items that aren't consistent with the rest of your item pool. And then you can use factor analysis to determine the potential different factors that make up your scale. So for example, like Matthew said, with trust, we have different parts of trust. So we have learned trust, we have situational trust, we have dispositional trust. Factor analysis allows us to extract these different dimensions from our overall scale and figure out which questions load on these different factors, so we have a better understanding of what we are measuring. And then once we have this final scale, we would want to actually deploy it and confirm that we have test and retest reliability. So if we deploy it in one group of participants and then in a different group of participants, with similar demographics, do we get similar results, which suggests that our scale produces reproducible results.
And what are some of the dangers of ignoring these best practices? What is going to be the result of my data at the end of the day?
There's a lot of dangers. So first of all, I think if we don't design a scale properly, then we may not be measuring what we think that we're measuring. If we don't couch these items in prior literature and actually verify internal consistency and do a factor analysis, then we could be measuring something different from the construct that we're intending. Additionally, when we do collect this data from Likert scales and we analyze this data, if we're not employing best practices when analyzing the data, then we could potentially have inflated type 1 errors, meaning that we are potentially rejecting a null hypothesis when it's true. And so this causes problems with reproducibility. And this was one of our main motivations for writing this paper, is because of the reproducibility crisis in psychology. We didn't want the field of HRI to experience these same problems with reproducibility. And so I think if we ensure that we design these scales properly and validate them thoroughly, and then employ correct statistical practices when analyzing data, then we can be more confident in our results.
The statistical practices are something I'd love to unpack. A bigger scale of data appeals to me very much as a data person because I feel like I have a more true story. Just asking, do you trust the robot, yes or no, is not going to get me as much granularity, but it does afford me a very easy statistical model. What do I do with the more complex distributional data I get from a Likert study?
Yeah, so one of the great things about actually using a set of items and then summing the responses on this set of items is that we can approximate interval data. So if we only have one Likert item and we're just asking participants to respond on one Likert item, then this is really ordinal data. And so we can't apply parametric tests, at least not properly apply parametric tests to ordinal data. But if we have a set of items and we sum these items, prior work has shown that these results can approximate interval data, and we can actually apply parametric statistical tests as long as the other assumptions, for example, normality and homoscedasticity, hold with our data. And so if we can apply these parametrical tests, then we'll have greater power. And if there is an effect, we'll be more likely to find it.
Could you describe one of those more, matrix-based Likert tests where you can apply that technique? What's it like, one versus many, for a reader who is trying to picture that on a survey?
There's many examples of Likert scales that utilize a set of items. One example would be if you're trying to measure the participants, how much they like a robot that they're working with. You could pose the statement, robots make poor teammates, and then have them rate from strongly disagree to strongly agree their perception of the statement. And then you could have another item where you ask, most robots are pleasant towards people, and then have them rate from strongly disagree to strongly agree on this statement. And then have, a series of more statements similar to these in which you have participants respond on the same response format, and then you would sum all of their responses to get an aggregate score. One of the things to consider with these Likert scales is it can also be good practice to have reverse items. So if you have a question where you say most robots make poor teammates, you could have another question where you say most robots make good teammates. And so by having these reverse items, you can avoid problems of acquiescence bias, where participants tend to rate the statement as more positive than they truly believe it to be.
Do you find that it seems like you would expect robots are good and robots are bad, the numbers to be kind of mirroring or one minus the other? Does it actually pan out that way?
We would hope that that is the case. And so if we have these reverse items, we can then measure the internal consistency of the scale to see if each of these items are consistent with the rest of the scale. So if reversing an item makes that item not consistent, then it may be the case that the reverse is not actually measuring what we're trying to measure, which sounds strange, but prior work has shown that sometimes reversing items can lead to this phenomenon. So it depends on the situation, but in some cases, prior work suggests that it may not actually be a good idea to reverse items if it decreases the internal consistency of the scale.
Yeah, we also find that people are just noisy. So people may literally in one thought say, this aspect of the robot's great, so I'm going to mark strongly agree. And then if you ask differently, and so maybe I'm going to say I disagree, or like I don't like the robot now, or this aspect of it. So that's why it's really critical to ask a lot of questions and not just one at a time. Some researchers I've met have suggested putting in a quality assurance question to like rate from, strongly disagree to strongly agree, the sky is blue. You just throw that in there, or like water is wet. And so they should rate strongly agree to that, or maybe you say it's the sky green at noon. They should say strongly disagree. And that kind of gets them to stop for a moment and like remember that they shouldn't just click strongly agree, strongly agree, strongly agree and be done with the survey and get their gift card and move on with their lives. They are just kind of quickly going through all those things and they miss these quality assurance checks, then maybe you have like a data integrity issue and justification to throw out that survey result. that's a continuing problem. We also find in some of our research, this is somewhat of a conjecture I think that Mariah and I are starting to develop, is that people with certain personality traits respond to these surveys and do studies very differently. Typically, people that seem to be more higher in trait conscientiousness tend to give us like what you might call quote unquote better data. They seem to be more responsive to the different conditions or treatments that we're applying. We kind of see a stronger signal to noise ratio with those participants. With people, there's always like a screw you effect where they're just going to say they hate it no matter what. There's going to be people having experimenter expectancy effect where they're just going to guess what you want and then put that, right? So it is a very complicated, messy science.
Well, having reviewed the literature, at least in the HRI field, how many prior studies that you looked at, or broadly speaking, were they consistent with your best practices, or were there criticisms to be laid on a lot of the historical literature?
Yeah, I would say that probably the majority of papers that we looked at had at least one kind of issue or deviation from best practices. It doesn't mean that the paper's results are wrong. It just means that perhaps the study could have been done a bit better. That's kind of this kind of understanding that we had from our own research and realizing we had made some mistakes in the past as a grad student learning. I still had room to grow. And so I was like, realizing my own mistakes or ways that I could have done it better. Not that I had the wrong result, but just that there could have been more rigor in the way that I analyzed it, and the drive to push myself to make sure that I can go to sleep at night really confident in the results that I have had spurred us to look at the field more generally and realize that there are some trends where there's these deviations from best practices.
Are there any common errors you saw creeping up again and again?
We did find a lot of errors related to misnomers. So people use the term Likert scale incorrectly a lot. And this seems like, a fairly benign mistake, but it can be misleading for authors and reviewers when this term is used incorrectly, because it can make it hard to determine what metrics the researchers are actually employing then. And also researchers tend to call the response format, it is a scale, but it's a scale from strongly disagree to strongly agree. They tend to refer to this response format as the Likert scale. And this is not actually correct. The Likert scale is the set of items that the respondent has to rate from strongly disagree to strongly agree. So these misnomers were very, very common. We also found a lot of common errors with regards to statistical tests. So we've found that a lot of papers did not properly check for assumptions when applying parametric tests to their data. And so this error is not specific to Likert data. Of course, you can make this error when analyzing any data, but we found that it was fairly common when analyzing the Likert data. So this is a problem because it can result in inflated chance of type 1 errors and potentially incorrect results.
Yeah, and unfortunately, what I think many reviewers may be able to kind of imagine their, a thought experiment. If you take 10 coins and you flip them all, one of them is going to probably be heads, at least. Even if the coin is weighted to give you a tails most of the time, if you flip enough coins, you'll get the rare result. If you roll enough dice, eventually you'll get a streak where you get a 6 over and over and over again, just by repeating the same trial. And that's kind of what a Likert scale is. If you say, I'm going to just test each individual item to see if I have a statistically significant result, a p-value less than 0.05. And that's, I think, one of the common trends that we did see that I've done in my own past research is like, well, you're greatly increasing the chance that you're going to get a positive result that's just due to random luck. And so you have to account for that on the back end to penalize yourself through something called a home Bonferroni method, or just a Bonferroni correction, or some other correction factor to account for that simple luck giving you the result that you want.
I believe you had some initial results a year, and then a year later were able to do a follow-up and see the degree to which perhaps the community responded. Have you seen an improvement in quality of publications in that time?
Our paper came out in the proceedings of alt-HRI. So that's human-robot. It's like the alt version of human-robot interaction. It's not exactly clear what that means. But we did have a paper in these companion proceedings. So not in the main track. We've done some to advertise when I go out and give talks. I'm mentioning this paper as a guide. Hey, it has the tips and tricks for you if you want to improve the rigor of your analysis. And we're starting to get some citations and some recognition of that work in our field. And we followed up with a journal paper now to try to make this much more big and salient and analyze results from a number of different conferences and the Journal of Human-Robot Interaction, and finding that these trends are ubiquitous. The issues are not just within one conference, but they're across many conferences and publication venues. So the time frame that we've had to get the work out there and kind of bring awareness to this, I think we haven't had enough time for it to have a significant impact or correction. But we are seeing kind of anecdotally from people that we've been able to talk to say, hey, I'm having my lab read this paper, or thanks for doing this kind of work. I think it's being received well, and we're very humbly grateful. And I mean that because it's kind of scary to put something out there that even says, hey, look, we've messed this up in the past too. We're just trying to all collectively work to make it better. And hopefully in 5 or 10 years, we'll see a lot of these best practices, and maybe somebody will come out with something that's even better than what we did and said, hey, there's even better practices, right? That's the ultimate goal.
Well, if you see a non-trivial frequency of these types of errors, it's good to be noting them and talking about it. Are these the types of errors that are going to adjust the second decimal point, or are they going to invalidate the history of studies?
It's hard to know. There's a spectrum where sometimes it's going to make a result potentially not significant. It doesn't mean that the alternative hypothesis is bogus now, but it does mean that you need potentially to rerun the numbers with a better test, with better metrics, try to replicate the study to see if it's true. And we should be doing that even if we get positive results, because sometimes there's just quirks of running a study with certain populations and demographics. And when you rerun that result, good or bad statistics, you can get a different result. And that's why you need a lot of replication studies before you can really be confident in the results that you have.
Well, I think it's fair to assume my interactions with robots will be monotonically increasing throughout my life, but have been somewhat limited to date. I've driven in a Tesla with autopilot once or twice, but I haven't worked at a factory where there's a lot of robotics. It seems somewhat new from my perspective. Having the benefit of looked at a few years of history, do you see trends in humans' perception of robotics? Are we changing, or are we in a somewhat stationary state?
Significantly. There's a correlation between trust and automation. There's a kind of a famous scale that assesses will you use an ATM? Or maybe, I don't know if your listeners will know what a VHS is. Would you use a DVR? Would you use an ATM? What do you think of an X-ray, right? So different technologies, basically with age, as with newer and newer generations, younger and younger people being born as digital natives, they are much more comfortable with embracing this technology. And then we also see culturally there's differences from east to west. Children in Japan grow up with cartoons where robots are your friends. And we grow up with cartoons, maybe, but more militarized, like Gundam Wing. But this is even anime we've imported from Japan. But think about Terminator. That's the stereotype. Is we like our killer robots. We love them mechanical, not soft and warm and your best friend. But I think as we become more global and as we really fully move into a digital native only population, we are going to be much more accepting of robots in our lives. One of the challenges, though, for robots, you may have seen, Google is killed off everyday robots. They're auctioning off thousands of new in-box robots because there's just this concern of potentially an economic downturn. And so you wonder, will there be kind of this winter? Autonomous driving isn't quite where it needs to be. And so Ford's pulling out of Argo. I think that tech companies are really realizing that these stable diffusion, kind of the fun art that you can do where you type in words and some DALL-E gives you a cool image, or what ChatGPT can do, that just real robotics in your life is so many orders of magnitude more difficult that it'll still be a while before you have Rosie in your home vacuuming and cooking you food. But maybe we'll make it a little bit faster with some of our research.
Can both of you comment a little bit about what's coming up next for you?
Yes, I can go ahead. So I actually just defended a week ago. So I'm currently on the job market, planning to do a postdoc. And so I'm planning to continue working in algorithmic HRI. So I'll definitely be using Likert scales in the future. there are a lot of interesting questions to explore in future research regarding the deployment of personalized robotic systems in the real world. So I'm interested in how we can improve the safety of these systems when interacting with real people and ensure that they're employing safe policies, especially when we're using these data-driven approaches. And then I'm also interested in some of the ethical considerations surrounding these personalized systems and how we can collect data from end users without violating their privacy, and how we can increase the transparency using explainability techniques.
Very practically,
yeah,
I'll be
I think that
submitting my
sums it up for
tenure
me.
package at the end of the month. So hopefully all goes well, and I'll be lucky enough to be promoted to associate professor in a year. So lots of thoughts on that. But in terms of our actual robotics research, I have a really fun system that I've been developing with about 30 different master's students kind of in our spare time to actually be my doubles partner for tennis. And so we have a journal paper coming out this year, and I'm really excited to have a system that I can start thinking about what does dynamic teaming look like in a way so that if the ball comes down the middle of the court and we both run for the ball, I don't get smacked in the face by the robot. So that's the fun project I have. In addition to the amazing research we do in autonomous driving, trying to work with Ford to deploy some of our learning-based systems and explainable AI. And then a really exciting new National Institutes of Health R01 grant we have trying to deploy decision support and autonomous control for robot-assisted perfusion in cardiac surgery.
And where can listeners learn more online?
Yes, so we do have our website. The CORE Robotics Lab has a website hosted by Georgia Tech. And then I'm on Twitter. Mariah's on Twitter. We get our work out that way as well. So if you want to see the cool latest stuff, Twitter might be the best way to go, at Matthew Gombolay for me.
Yeah, so you can also find me on Twitter at Mariah17Shrum, and then also at my webpage, mshrum17.github.io.
Excellent. We'll have links to all of the above in the show notes for listeners to find. Well, thank you both so much for taking the time to come on and share your work.
It was a pleasure. Thanks.
Thank you.
Well, that's it for this installment of Data Skeptic All About Surveys. As I mentioned in the intro, if you've got a good book recommendation specifically for a nonfiction book about what's going on right now or in the future with artificial intelligence, do email me about it. I'm compiling a list. See you next week, everybody.